In number 21, we're asked to solve this polynomial. So we're going to start by looking at its graph. So in the graphing calculator, we're going to enter negative x cubed and then plus 5x squared. That's plus 7x and minus 51. Then zoom 6 will show us a standard negative 10 to 10 window, and I can see that it's crossing here at negative 3, so I can start my synthetic division with that that real zero. I also see there's a turning point here that does not touch the x-axis, and that means there's going to be two imaginary zeros. So I have one real zero at x equals negative 3, and then I'm going to end up with two imaginary at the end. So my coefficients are negative 1, 5, 7, and negative 51. And we're going to start by bringing down that first term, and then we multiply. Negative 1 times negative 3 is 3. Then add 5 plus 3 is 8. Then multiply. 8 times negative 3 is negative 24. Then we add 7 plus negative 24 is negative 17. Then multiply. Negative 17 times negative 3 is 51. And add negative 51 plus 51 is 0. That 0 is the remainder. That's preceded by the constant, the x, and the x squared. So my factored form then is going to be an x plus 3, a negative x squared plus 8x minus 17. And that's equal to 0. If I factor out that negative leading coefficient to the front, that's going to change all my signs in that quadratic trinomial to x squared minus 8x plus 17. And then this quadratic trinomial does not factor, right? I know from the graph because I saw there would be imaginary zeros, but I also see that there are no factors of 17 that add to equal negative 8. So we're going to use the quadratic formula where a is 1, b is negative 8, and c is my constant 17. So x equals negative b plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. So when we excuse me, when we evaluate that negative 8 quantity squared is 64 minus 4 times 17, and that equals negative 4. So we have x equals 8 plus or minus the square root of negative 4, all divided by 2. That is 8 over 2 plus or minus 2i over 2, which is 4 plus or minus I. So my zeros, I have x equals negative 3 as my real zero. X equals 4 plus I is an imaginary zero, and then its conjugate, x equals 4 minus I, would